All right, hello and welcome everyone to the session 3 of this 4-part series. Um, I am Utsav Shah. I am your instructor for today, and we are going to learn all about SQL. So, in the last two lectures, we built up a lot of base in terms of the selection queries, the conditional queries, how to filter the data, how to aggregate the data, how to sort and order the data. In the last section, we learned more about the string functions, the date functions, and different kinds of functions, and how to write a subquery as well. Today's session is extremely important. It talks about different kinds of SQL joins. So let's start by learning more about SQL joins. All right. Welcome everyone again. Um, so for today, we'll introduce you to two new data sets. One is the e-commerce customers data set, and the other one is e-commerce orders data set. So these data is taken from open data sources and has been run in a way where we can build our own schema. So everything now is under the career underscore nub schema, and hence you can query any of our databases under the career underscore nub schema. So the e-commerce, let's look at what exactly is the customer's dataset and what exactly is the orders dataset before we begin solving on questions of SQL joins. All right. So the e-commerce customer dataset, let's run a simple select star on this. So if you're completely new, if you want to select all rows of the data, you need to mention select. Star means you will get all columns or fetch all columns. From, you need to mention the table name. And then at the end of the query, I just like to mention that it's limit 100 so that we only get 100 rows and we don't get all the rows of the table because we just want to look at the table and have a feel of what the content is. All right. So in the customers table, we have the customer ID. There's something called as unique ID. So it generates on top of the customer ID. We have the customer zip code. So where exactly is the customer from? We have the city of that particular customer. And we also have the state. This e-commerce data set is from Brazil. So all of these are states or sort of different area. So SP is different. Like these are different states within Brazil, right? And then if you look at the cities as well, Sao Paulo is the biggest city in Brazil. So that's also all related to Brazil, right? So that's the customer data. It has 5 columns: the customer ID, the unique ID, the zip code, so locational information, the zip code, the customer city, and then the customer state. Okay. Let's look at what exactly is the orders dataset, because these are the two important data sets that we are going to use for today. Let's use this. All right, it has more columns. And what exactly does it have? So it has the order ID. So all of these are order level information. Okay. So it has the order ID, the customer ID, which customer ordered this order, what's the status of the order. So let's say you place a order on an e-commerce website, so Amazon or any other e-commerce websites which is available. Wherever you order something, you will see that the order status, if you check, there would be purchased or dispatched or in transit or whatnot. And then finally, when you get the package, the status might change to delivered. If it isn't fulfilled or it's not available, then there are different order statuses like unavailable, You scroll down, there would be different order statuses as well. But the most important is that the order is delivered. So that's the one of the core status in the order status column. Okay. Now, at what time do you purchase the item? That's this column. So all of these are date columns. So order purchase timestamp. Order approved at. So once you order, the e-commerce website has to approve your order. So that's logged here. When does the e-commerce website hand over the package to the carrier or the courier? That's this timestamp. And then finally, when do they actually deliver to your final homes? And that's this timestamp. There's one other. If you order on any e-commerce website, they generally have a estimated delivery time, so that your order is going to reach in 5 days or in 7 days or whatnot, right? So that's captured here. Don't worry about too much about all of these dates. Just remember that whenever you purchase the order, that's logged here in the order purchase timestamp, right? So as you can see, we have two different data sets. One was at the customer level. So the granularity was at the customer level. We could get different um, data points about our customers. And in the orders, it's at an order level. So we get all the details about the order itself, right? If you notice that the customer ID is actually present in both of these tables. We'll talk more about it on what does that mean and how we can use that to generate better insights, right? Cool. SQL joins. Let's learn all about SQL joins. This is again a very, very important topic. At the base, a SQL join is when you combine two or more different tables. All right. So it's a combination of tables and to analyze data, right? So generally, as we had done in the previous two sessions, rarely in industry there is everything available from the single table, right? And you have to join or you have to combine tables, different tables to get the kind of analysis that you want or solve your problem. All right. There are different kinds of SQL joins. We'll talk about two most important SQL joins, and then the rest I'll just explain on how to do them. Right. So the first and the foremost, which is the key one, is inner join. So let's see what exactly is inner join. Again, our approach is to get a question in front of you and then break it down into different slices to make you understand what exactly are these concepts and how do you go about solving them. Okay, so get the question here is get is and feel free to keep asking your questions in the chat. Cool. So the question is get the number of orders placed from each state using these data sets and then sorted by the highest orders. Okay. Now let's see this order column, order data set. So if you notice there's no state, there's no customer state. So how are we going to calculate the number of orders from a particular state? So let's say if the question were um, calculate the number of orders by each order status, we could have run a very simple query. The query would be select count of order ID as orders. Let's do from orders dataset. And we could have used the order status column and just aggregated that. So group by one or group by order status, anything would work, right? And then let's put in a limit of 100 and let's run this code. So now you have all of these different order statuses, which is shipped, unavailable, invoice, created, approved, processing, etc. And you have the count of orders, right? However, the question says that we need to find the number of orders placed from each state or customer state. But if you had noticed, we did not have the customer state in the order dataset, right? But we have the customer state in the customers dataset. So let's actually query the customers dataset quickly. So you see that we have the customer ID and then we have the customer state here as well. Okay. So now what we can do here is intelligently combine both of these tables. All right. We're going to combine both of these tables so that we get the customer state mapped to the customer ID in our order dataset. So again, our order dataset was this one. You see that it has a customer ID. In the customers dataset as well, we saw that there is a customer ID, which means that we can combine both of these tables and map the customer ID of both of these and get the customer state. Okay. Let's try and do that, and let's see what function do we use for that. So instead of this, let's remove group by as well. So let's rename this as EOD. You know that aliasing we learned in the first session. It's extremely powerful exactly for these reasons. So now what you can do is alias your table names, right? So karyanup.ecommerce orders data set, you can reference it as EOD. Let's join this to the um, customers data set. And let's rename the customer data set as ECD. So that's e-commerce customer data set. And this is e-commerce orders data set. Now, whenever we join, we need to mention what column are we joining on. How would you combine both of these data sets, right? What is the condition on which you need to combine both of these tables? Okay. So what's the common column between these two? So you mention on EOD dot customer ID because that is the common column here. And that's also present in our customers data set. So that's is equal to ECD dot customer ID. Okay. Let's just select star so that we know when we do this, what's the output that we are getting once we join these two tables. Let's run this. All right, so now you have, because your from table is the orders data set, you have all the columns of the orders data set first. So you have the order ID, you have the customer ID, which it says that it's a duplicate column because the customer ID is also present in our customers data set. It has the order status, the order purchase time, approved at, delivered courier date, delivered customer date, estimated delivery, all of these columns. Now, if you stop here, that was the orders data set till the first column, the order ID till here. Now, because we have joined with the customers data set, we also get all the columns from the customers data set. So we have the customer ID, we have the customer unique ID, which is present there. We have the zip code of where the customer lives or has ordered from, the city of the customer, and then finally the customer state. Okay. So now with the ability of join or with the function join, we combine two different data sets on a condition. The condition is that every row, or it will check for every row, wherever the customer ID, EOD customer ID is equal to ECD customer ID, that is where it will get joined. So if you look at the customer ID here, this is 06B8 999, etc., etc. And let's compare this value with this. So you see that the customer ID here is exactly the same as the customer ID in the customer's data set. And that's how it's able to join. So it can join on any condition. And the condition could be equal to, as we have seen, it could be greater than, it could be less than, it could be between, and whatnot. And whatever different conditions that you want to mention, it will join on that particular condition, right? Whenever that condition is true, it will match these rows and give you the join of the table. Right? The most commonly used is obviously the equal to sign. So wherever there is a common column, we are able to join that those two data sets. Okay. All right. So now we have got the select star. Let's do EOD dot customer ID, comma ECD dot customer ID as well. So just to run this once again, let's we run this. And now you see that we have both the customer ID. So we have the order uh, customer ID from the order dataset, and we have the customer ID from the customer's dataset. And you'll see that all of these columns would match because that's our condition. That's what we have conditioned the data to join on. Okay, cool. So once we have got everything, let's do the select star again. And you'll see that now we have the customer state. We know once we have a table, once we have a column on which we have to count anything or aggregate anything, we'll use that as a dimension. So let's use customer underscore state. What do we need to do? We need to find the total number of orders for each customer state. So let's count the order ID and rename this as orders. Let's also rename this as just state. So we have the customer state, we have the count of order, which are just the total number of orders. And because we are using aggregate functions, we need to use a group by clause. So let's do group by, and we can do customer underscore state. Now, usually whenever you use joins, make sure that you alias the column names as well. So customer state is coming from the ECD column, ECD dataset. So that's the e-commerce customer dataset. And the order ID is coming from the EOD dataset, right? So that the system or SQL knows which column is coming from which dataset, and it's easier for it to query. Okay. Let's try and run this, see what output we get. Perfect. So now we have gotten what we wanted. We got the number of orders or the count of orders, and we got it by the customer state, right? Which we have renamed it as state here. So that's how we've combined two different tables on one particular column, and then use the entire table or the combined table to aggregate functions. And the aggregate functions, you already know how to do it, all right? So there's one last thing. So get the total number of orders placed from each state using these data sets and sorted by the highest order. So let's just order, sorry, order by, and we'll order by the second column, which is the orders. And because it's highest to lowest, we'll just use DSE, which is descending. And let's run this again. Perfect. So that's your code. We see that the state SP has the highest number of orders. It has about 29,000 orders. RJ has about 9,000, etc., etc. Right. So you've used two different tables. You've combined them, and then use the aggregate functions to know the total number of orders. So when we share this sheet, I've mentioned the steps on how you can do this, how you can reach there. join both the data sets on the common column, which is customer ID, to get a combined table. Calculate the number of orders by using the count function on the order ID from the order ID is present in the orders dataset. Break this down by each state or the customer state using the group by clause, and then finally sorted by highest to lowest using the order by DSC function. Okay, so this is how you can solve most of the questions by breaking down into different steps. And you've also learned what exactly does a join do, right? Now let's look at one other example with conditional filtering. Okay, so it's almost the same question, which is get the number of orders placed from each city. So instead of state, we just need to use city within SP, the state SP, using these data sets and sorted by the highest orders. So it's almost the same question. However, what we need to use is city, and then we need to apply a condition where state would be equal to SP. So let's run the query again. Let's see how we can do it. So select star from orders dataset, and we can rename this as EOD. We will join this on our customers dataset as ECD. We need to mention on what condition does this join happen, or when this whenever this condition is true, that's where the join would happen. So we mentioned that EOD.customer ID should be equal to the ECD.customer ID, and that's where we want the join to happen. And let's just run this as a limit 100. Perfect. So when we ran this, we have seen this, that there are all the columns from the order data set, and then there are all columns from the customers data set as well, right? So now what we need to do is we need to get the, sorry, I'll just copy paste it before the steps. Cool. So get the total number of orders placed from each city. So now we have to use city within SP, or within state equal to SP, right? And then we have to sort it. The sorting is fine. What we need to do is count the number of rows, count the number of orders for each city. So let's do that. Let's use the customer city. So ECD dot customer city. Let's rename this as just city. We can use the count of order ID as orders. And let's run this. So we need to group it by the customer city to get our aggregation functions going. So it's almost the same query. We just replaced the state by the city. So you'll see that we'll get the orders by the city. These are all the different cities. There's one other thing. We have to only restrict it to cities which are within the SP state. There's a state named SP. So we need to apply a condition. So for any condition, we can use the, you know that we need to use the where condition. So where ECD dot customer state is equal to SP. And let's run this. Perfect. So now you see that it has filtered on the state SP, and it has calculated the number of orders. One last thing to do here is that we need to just order this by. So let's order by 2, which is the orders column, and we have to sort it by highest to lowest so that we can run our analysis. Perfect. So now you know that Sao Paulo, which is the biggest city, is featured here. So it has 10,000 or 11,000 orders. Campinas and all of these different cities within the state equal to SP are present here, and we have calculated the number of orders, broken it down by the customer city. Okay. This is what we wanted. So this is how you can use filtering as well. Now there's one other way of how you can use the filtering. As we see that the ecd.customer state is obviously present in the customer's data set, what we can actually do is, you know that we are providing conditions on where when we are doing joins, right? So you can actually introduce another condition. So you can mention, so let's comment this out. So on customer ID or order data set customer ID is equal to customer data set customer ID. And you can mention that the ecd.customer state is equal to SP. So that at the point of joining these tables, you filter out the data for only customer state. Okay. This becomes extremely important if you're dealing with huge amount of data sets and whatnot, because the difference between the two is that when you mention a condition under the join function, it filters out the data first and only joins them, right? Because this would only join if both of these conditions are true. Okay. However, when you apply a where condition, it will first combine the both the tables and create the whole data set, and then run a filtering process on top of that, right? So let's say if you have I don't know, two different data sets which has 10 million rows, and the condition that you're applying is only for a million rows, then based on this on the join, it will only join the million rows. So you'll get 1 million rows, and then you can do whatever aggregations that you want. However, if you apply a where condition, it will join the entire 10 million rows, right? Wherever the conditions are true, right? And then perform a filtering on top of that. This is more cost effective, mentioning conditions on join if it is relevant. And hence, this is a advisable option for you folks. Whenever it's possible to use conditions or more conditions filtering, just make sure that that's in the join so that it's cost effective for the entire program. Let's run this and see if we get the same output. Perfect. So now what has happened is you have done join and filter and then joined. So you've done a filtering process and then joined, and you get the same results, right? In the where column, or where conditions, what you are doing is you are joining first and then filtering, right? And in this, you're filtering first and then joining. Filtering first and then joining, that is more cost effective compared to the other way around. Okay. So now you've learned how to join, and you've also learned how to run filtering on top of joins. Let's, and I've mentioned the steps here. So you need to join both the data sets on a common column, calculate the number of orders by using the count function on order ID, break this down by each city using the group by function on customer city, and then you can apply a conditional filtering while joining the data sets using the AND function. So on condition and on customer state. And then finally, you just need to sort it by the output, which is the orders from highest to lowest using the order by DESC function. Perfect. So what we learned till now was just a join. Whenever you mention join, it by default means an inner join. Okay. Uh, I'll explain how exactly is a left join different from an inner join, and what does it do, and how it can help us solve some of the questions, the following questions. So in inner join, what happens is whenever you mention the condition. So for example, you mentioned here that the customer ID should be equal to customer ID, and then the customer state should be equal to SP. It will only join if these conditions are true, right? And the final output also will only be the rows which have been joined. Okay, so any row which is not joined will not be present. So hence it's an inner join. Wherever the conditions are true, only then you will push it to the output data set, right? Let's see what exactly is left join. So it's a simple question. It looks like a simple question, but it will explain how we can use left join and solve this. It says find all customers who have not placed an order. Okay, so in the let's actually query the orders data set again as EOD. Let's apply a limit 100. Let's quickly look at what our orders column was, orders data set was. So in the orders data set, we had the granularity at order level, and each order has its own customer ID. So customer ID, order ID combination. Now, there you won't find any row here for customers against which there is no order ID, right? So only if a customer has placed an order, it will be in this orders data set, right? But what about the customers who have not placed an order, right? Where are these customers and how can we find them? So let's copy this, and instead of the orders, let's look at the customers data set. So the customers data set is actually all the data set, all the customers which are present in the system. Okay, they might have registered or logged in the e-commerce website, but probably not placed an order. So they could have placed an order or not have placed an order, right? There could be two things. So let's say you go on Amazon, you create an account, you look at some products, but you don't find anything interesting, and hence you don't buy, right? So you'll never be in the orders data set. So we want to find out those customers who are present in our customer data set, but they are not present in the orders data set because they have not ordered, right? That's what the question is. So find all customers who have not placed an order. Okay. So let's see how we can use both of these tables to get that. So in the normal join process, let's join this quickly. So now you know that you can join by using the on condition. So the on condition, so this would be the ECD data set. So on ECD dot customer ID is equal to EOD dot customer ID. Okay, delete this. And let's quickly query. Now you know that that the output of this, you will get all the customer information first, and then you'll get all the order information. However, it will only join if this condition is true. So let's just do one thing: ECD dot customer ID, EOD dot customer ID, and let's run this again. So what we have here is the first column is from the ECD or the customer's dataset, and the next column is from the EOD or the orders dataset. Okay, so you see that all of these rows are equal, which means that we have joined only when the condition is true, and that's what the join or the inner join does. Now let's rename this as customers and customers who ordered. Okay, and let's rerun this query so that it's cleaner. So you'll see that customers is equal to customers who ordered, and you get all the rows where both of these are just equal, because we've mentioned that we have to join it, right? And that's an inner join. Let's just see, what does a left join mean here? Okay, and I'll just explain how it functions. So this is a great example. Perfect. So now you have a customer. This is this person, 18955, whoever the customer is. They registered on the website, or they are present in the customer's data set, but it could not find any order related to that. So that particular customer was not found in the orders data set. Okay. So what does the left join do? So left join preserves all rows from the left table. So the left table is the from table here. The from table is the e-commerce data set, right? And what's the right table? The right table is the e-commerce orders data set. So it looks at left table. It takes all the rows from the left table because it's a left join, right? So left join means everything from the left. Right join exactly means everything from the right. Okay. So in left join, it will take all rows from the left column, or the left, table, and then join it with the right table only when the conditions are true. If the condition is false, or it doesn't return any output, it will also not return any output, right? So in this example, you can see that whenever the condition is true, it will give out the customers who ordered, or the customer ID. And if the condition is not true, then it will not give out the output, right? So cool. So now the question was, find all customers who have not placed an order. So this is just the condition, or the status of a customer, whether they have placed an order or not, right? So for example, this customer has placed an order, this has not placed an order, all of these have placed an order, this has not placed an order, all of these have placed an order, this has not placed an order, so on and so forth, right? So what we need to do is we'll just apply a filter after joining both of these, that the customers who ordered, which is the eod.customer ID, is null. So you see that this is empty in some of the SQL IDEs. If you run this query, it will throw out a NaN or a null, but all of this can be checked by this condition, right? So what this condition says is that give me all rows where the customer ID from the orders dataset is null. There is no output out of that. Okay, let's run this. Perfect. So now you see that you have so many customers in the customers dataset who are not present in the orders dataset, which means that they have not ordered, right? So you have solved the question, which is you've found all the customers who have not placed an order yet. And who are these customers? These are all the customers that you can get. Perfect. So now you know what does a left join mean. Again, repeating. The left join means that you get all rows from the left table, and you join it with the right table, and you return the output where the condition is true. But if the condition is not true, it will preserve the rows on the left table, but it won't throw any output, or it will throw a null output on the right table. Okay, cool. Let's do one more example, and I've written the steps here as well. Make sure that both the data sets are joined on a common column, which is customer ID. The join is a left join, so that you get all customers from the e-commerce data set. You can select the customer ID from both of them, and then filter on the customers where they're not present in the orders data set. Cool. Let's do a similar question, and and see if we can solve it. So it says what percentage of total customers have placed an order, right? So now we want to know, right, this was just the customer list, but how many customers actually placed an order? Okay, so let's just see what's the total count of customers, right? Customer ID has total customers from the customers data set as ECD. And let's quickly put a limit to see how many total customers do we actually have. So we have about 99,400 customers overall, okay? And let's quickly count how many customers do we have in the orders data set. So the orders data set, let's rename this as EOD, change it here as well, and let's count. We have about 70,000 customers in total customers who ordered. So let's change this. So that's 70,000 customers. So roughly, you know that of the 99,440 customers that we have at an overall level at the customer data set, only about 70,000 of them are present in the orders table, right? So roughly it's 70%. How do you do this in a single query and not do the math in our head and have that result outputted? We just did. We had to do a left join between the two. So let's actually use both of this. So let's use this. The customers who ordered from, you know that the left table has to be the customers table. And then we can join the customer orders data set as EOD. You know that this will be a left join, and ECD.customer ID will be equal to EOD.customer ID. Let's put a limit and let's run this. So you've already seen this query. Whenever you run this query, you will get the total customer, the customers in the customers data set on the left, and the customers who ordered on the right. If it's present, it will be joined. If it's not present, it won't be joined. It would be a null output, right? So what you can do is you can, because we need to find a percentage, we first need to count how many total customers were there who ordered. So that would be, let's comment this out. Let's count this who ordered, and then the count of the total customers, right? So if you count ECD.customer ID, which is coming from the customers data set, which is your first column, you'll get the total number of customers. If you calculate the right column, which is EOD.customer ID, you'll get the total customers who ordered, right? Let's see the output of both of this. We roughly know what the output should be. It should be that 70,000 customers were number of customers who ordered. And then at total, we have 99,400 customers. Okay. We need to find a percentage. So you can just quickly reuse this. Let's multiply this by 100.0 and divide this. That's our denominator. And you'll see that, so it's EOD.customer ID, which is this column, divided by the overall customers or the total customers, which is this column, right? And let's say that this is percentage of total customers who ordered. Okay, let's run this. Perfect. You did it. So now you have the percentage of total customers who ordered, which is equal to 70%, 70.4%, right? So this is how you can use left join to find out different combinations and preserve all the rows on the left table. Let's run the same query, but instead of left join, let's use the inner join. So let's just copy the entire query, remove the left, and let's run this again. Let's see what output we get. So we know that if we use an inner join, we will only allow the join to be happening when the condition is true, and it will not preserve all the rows of the left or the right table, right? It will join both of these tables and just give the combined output. Hence, you see that it joined where it found true. So the total number of customers who ordered was 70,000, which is same as previous one. But then the total customers as well was reduced to 70,000. So it could only join on those particular rows. And hence you see that the total customers who ordered is actually 100%, which is not correct. The actual count should be 70%, which is coming through this query. Cool. So now you've learned the inner join, how to perform an inner join. How do you combine both of these, different kinds of tables on a specific key? And you can mention different conditions. You also know the difference between an inner join and a left join. Left join is where you preserve all the rows from the left. Very similar to this, if you if you write right join, it will preserve all the rows from right. It's very similar to left. So any examples that you have, you can just switch between these two, between left and right. And so you've done all of this, and you've also done some analysis based on the questions. All right. Let's move to and I've mentioned the steps. Let's quickly walk through the steps. So join both the data sets on a common column, which is customer ID. Make sure the join is a left join, so you preserve all customers from the customer's data set. You can count the total customers of the customer's data set, and you can also count the total customers who ordered from the orders data set. When you divide both of these, you can actually get the percentage, which is about 70%. Right? Cool. Let's learn more about self-join. What does the self-join indicate? It indicates that you have to join your table to the same table, right? So it's joining with itself, and that's essentially what a self-join is, right? Where is this used? Wherever we want to find conditions which are true within the group or within the data set, that's where we use this. It's an extremely frequent question, extremely in interviews or where you're preparing for exams and whatnot. Self-join is extremely tested. And it's also used in the industry for quite a while. So the question is pretty simple. You have to find customer pairs who ordered at the same time, right? Remember the order purchase time. So if you don't, let's quickly write a select star from as EOD, limit this to 100. And let's see what the output for this is. We already know. We get all the order information. So you get order ID, the customer ID, the status of the order, whether it was delivered or unavailable or all the others. And then just focus here, which is the order purchase timestamp. Okay. So now you have the question where you have to find customer ID pairs where the order purchase timestamp is the same. So they have to have ordered at the same time. Okay. So how do you do this, right? The easiest way to do this is using a self join, right? So what essentially you can do is rename this as EOD1, right? And if you join the same table on the same table using a um, an inner join, what do you think the output would be? The output would be just the same number of rows. Okay, so let's check how many rows do we have in this as rows, and you'll see that the number of rows are 70,000. Okay, now let's join it with the same table. And how do you do that? So what you can do is just use a different alias, right? So it will be the same table, but the system will think that's EOD1 and it's EOD2. So you have two different tables. So this is how you can use a self join. You need to mention what condition. So let's just for now join it on the customer ID. Customer ID. And it will join whenever this is true. Essentially, if you're joining, this doesn't make any sense. It should return the same output. Let's check that. Let's count the number of rows, and it should be 70,000. Correct? So it doesn't make a difference if you join it on the same row. Now, what do we need to do? We need to find out. So let's query this again so that we have all the columns in front of us. So select star, limit 100. Let's do this again. So now we have all the columns in front of our eyes, which is orders, customer ID, order status, and order purchase time. So what we want to do is we want to join it with the same table, but we don't want that the customer ID should be equal to the customer ID because we want to find different customers, right? So, and the other condition is that, so this should be not equal to, or you can write not equal to like this as well. That's a condition. So they shouldn't be equal to the same. It shouldn't join on the same customer ID, and it should join when. So we need to find the customer pairs who ordered at the same time, which means that the EOD1 dot order purchase timestamp should be equal to EOD2 dot order purchase timestamp, right? So now you are saying to the system that give me all rows where the customer ID was not equal to that customer ID because we don't want the same customers. We want different customer pairs who ordered at the same time, which means that the order purchase timestamp should be equal to the order purchase timestamp in both of these tables, and the customer ID should not be equal to, right? Let's see what the count is. So the count should be reduced, obviously. And let's see. So there are 568 times in the same table where different customers have placed an order at the same time, right? Where the order purchase time in that particular row was equal to the order purchase time, right? So this is how you can use self join. Let's actually EOD1 customer ID as first customer and EOD2 customer ID as first as the customer pair. Okay, let's query this. And you will see that you have the first customer and you have the customer pair. Now let's check what their purchase time was. So EOD dot order purchase timestamp as first customer order time. And then let's do this, which is EOD2 dot, and this would be, let's rename this as customer pair order time, right? Let's check what the order times for these are. And that's where you'll see how we have used the condition. So if you look at the first customer order time, which is 2018 704 21 54 37, that's the timestamp. If you look at the customer pairs order time, that's exactly the same, right? So these two customers, 9F38AD, etc., and 56CCD3, etc., they placed an order at the exact same time. The timestamp was sometime in 2018 0704 21 54 37, right? Those are the exact conditions that we have here, which is that purchase timestamp of the first customer should be equal to the second customer, so that we get all customers who placed an order at the same time. And we don't want it to join on the same customer, obviously, right? So that's where we put this condition as well, right? So this is how you can self join or use the same table to join with itself, right? To find these solutions to all of these different sets of problems, right? Does that make sense? Any questions that you have, please post it on the chat. We are almost at time. Today, we learned all about Sql joins. We started by learning about how joins are a combination of different tables, two or more different tables, and we can analyze more data based on this. In the industry, rarely everything is in a single table. You always have to join and find intelligent joins between different tables to solve your questions. We looked at the inner join, which is just joining on the condition that you mentioned. If that condition is true, it will result in the output. If it's false, it won't give any output on the result, right? If so, that's how we use the customers and the order data set to calculate the number of orders by customer state, which were present in different tables. We used a condition as well, and how we can use the condition both in the where clause and also while joining. So while joining, you can use the same condition by just mentioning and. We moved on to solve questions on the left join. Left join, again, preserves all the rows in the left and joins it only at the conditions where it's true. If the condition is false, so if this condition is false, it will just result in null output. Right? However, it will still preserve the left-hand side rows. Okay. So that's one of the key things to note. We calculated how many customers have not placed an order, which is about 70,000. And the total number of customers were about 99,000. So about 70% of our customers in our database had actually placed an order. Right? And lastly, we talked more about self joins and how we can intelligently join the table on itself to solve different questions, right? So in this, we solved finding those customers or customer pairs who had ordered at the same time. So we used the same table and joined it with itself. However, the conditions were that the customer ID should not be equal to the customer because we don't want the same customers. And the order purchase time should be equal to the order purchase time of the other customer. Right? We saw that there are about 568 customer pairs who have ordered at the same time. One of the example is using this. We know that this customer and this customer placed an order at the exact same time, right? So this is how you can use different kinds of joins based on the problem that you're solving. I'll share this file without the code and with the code as well. I've tried to mention the steps. So whenever, again, repeating myself, whenever you get a question, please break it down into different steps, into simpler steps, so that you can, whenever you code, it's easier to code. And we will do how you can use all of these steps to actually come to the final answer, final conclusion. Right. We'll be announcing and we'll be sharing all the details about the session 3 in a while. And then we'll also announce how you can get a certification out of this course by doing our assignment, and then we'll send out the assignment as well. All right. So thank you everyone for joining in. And whenever you're watching this, hopefully you learned a lot, and I'll see you in the next session. Thank you.